In this lesson, we're going to learn about powers of I. So what we're going to be doing is taking some examples that look like this and simplifying them. So we're going to have our imaginary unit, our I, and we're going to be raising it to a certain power, and it's going to equal one of four answers, which you will see by the middle of the notes. So before we start, we just want you to add on our definition that we put in our last note sheet, and don't forget to put your heading, pause your video if needed. Can you start off by writing your definition of an imaginary unit? So we're going to write imaginary unit. What that means is it's the number I, and I is our symbol. So it's the number I, which is not a real number. You can use your number symbol if you want, which is not a real number, where the square root of -1 equals I. So we talked in the last unit that if we have a negative underneath the radical, in order to simplify it, you can change that square root of -1 to the symbol I. Now what we're going to talk about is powers of I. So I'm going to write powers of I. And what I mean by that is if we have an I raised to a certain power, these all can be changed to one of four answers. So if we have any of these, no matter what, it could be any exponent, it's always going to be one of four answers. And we're going to learn how that would be right now. So can you write for me? Can be one of four answers. And here's our examples. So we have number 1, number 2, number 3, number 4, just so you can see where this is coming from. They're all going to be based on I to the first through I to the fourth. So can you write for me I to the first, I to the second, I to the third, I to the fourth. So if we have I to the first, that one seems to be simple. We just drop the 1, that's imaginary, so that's just I. So anytime you have the square root, you have I to the first power, that's 1. I to the second power, I'm going to use this example right here. I know that I is the same as the square root of -1, so I'm going to change that. I'm just showing you where these answers are coming from. I'm going to change this to the square root of -1, and I'm going to square it. So again, if I know that I is equal to this, if I want to square this, I'm just going to square my radical. Well, you know that the square and a square root cancel out, so if I do that, I'm just left with -1. So anytime we see an I squared, that is going to simplify to -1 because we're just squaring a radical. I cubed, I can use both of these rules. I know that I cubed is the same thing as I squared times I to the first. And I'm using my rule of exponents. If I add 2 plus 1, I'd get 3. Well, I know from the previous rule that I squared is -1. And I know that I to the first is just I. So if I was going to go ahead and simplify that, -1 times I is the same thing as -I. So anytime I see I to the third power, I can just rewrite it as I is -I. So again, these rules are just helping you see what our four answers are. You will not need to memorize any of this. Well, I to the fourth. I'm going to change that to one of the rules up here. I know that I to the fourth, I can break it down into I squared times I squared. Do we already know what I squared is? Well, if you look here, I squared equals -1. So this would be the same as multiplying -1 times itself. So -1 times -1. Well, -1 times -1 is 1. So that means I to the fourth is going to be 1. So what I showed you, you do not need to know any of this. Anytime we have a power of I, these are the four answers we could possibly have. And what happens is it's kind of like a rotation. I'm going to show you with the clock. So I'm going to make this little clock here. I'm going to make some room around it. And on the outside, I'm going to put I to the first. Let me move this. I to the second, I to the third, and I to the fourth. Can you draw that for me? what's going to happen is every time we add on an exponent, it's like we rotate more and more around this clock. So we know that I to the first is 1, so I'm going to put a 1 inside my clock. I know that an I squared is negative 1, so I'm going to put negative 1 inside. I to the third was negative I, and I to the fourth is 1. So I want you to notice that if I wanted I to the first, it's here, I squared, I cubed, I to the fourth. If I wanted I to the fifth, that would be the same as adding on 1 to this. So if you notice, we would just move down. So I'm just going to put I to the fifth out here, because I to the fifth would be 1. If I wanted I to the sixth, that would be, I go around 1, 2, 3, 4, it's 2 more away, 5, 6. So this is the same as I to the sixth. What I'm trying to show you is any power of I can be used by using this clock. You're just rotating around. So we've got I to the first, I to the second, I to the third, I to the fourth. I to the fifth would be 1 more than 4. I to the sixth would be 2 more exponents than 4, so that's why it's down here. I to the seventh would be over here. And then I to the eighth would be up here. If I continued, I want you to notice 9, 10, 11, 12, multiple of 4, 13, 14, 15, 16, multiple of 4, 17, 18, 19, 20. So anytime you have an exponent that's a multiple of 4, it brings you right back to this 1. So we can use this clock to get our higher exponents, and I'm going to show you how to do that now. So I'm going to pull this off and keep this in front of me so I can see it. And I'll make you some examples. So this is example A. So can you write for me? Simplify. Good enough directions. We're going to do 8 of these. So we're going to do 1, 2, 3, 4. So in our table, we've already done our powers of 4. We've done I to the first, second, third, and fourth. Now I want us to add on I to the fifth. I already showed you in the table that I to the fifth is just 5 spaces around. So 1, 2, 3, 4, 5. So that's a 1. I'm sorry, this should be an I here. Make sure that's an I. That's definitely an I. So this is I to the 4. I'm sorry, this is I. Let me explain this another way. What you can do is take out a group of 4 and see what's left. So for instance, I know that this is the same as I to the fourth times I to the first. My I to the fourth, if you notice, is always going to give me this 1. So I can just cancel this out. So my answer is just going to be I to the first, which is I. The more I explain it, the more the easier it will be, I promise. The next one, I to the sixth. I can use my clock and go around 6 times. So I can go 1, 2, 3, 4, 5, 6. So I know my answer is -1. Another way to do that is you can take out a power of 4. So you can write I to the fourth and see how many you're left with. Well, 6 minus 4 is 2. So that's I squared. You know that I to the fourth is just 1, so it's going to cancel out. So your answer is just left with your remainder, your I squared. If you look at your clock, I squared is just -1. Let's try another one. I to the seventh. I'll start over again. There's 2 ways to do it. You can use your clock and go 7 spaces around. So you can go 1, 2, 3, 4, 5, 6, 7. So our answer should be -I. Well, the other way to do it is take out I to the fourth and see what you're left with. 7 minus 4 is 3. So you have I cubed. You know that I to the fourth is just 1, so that cancels out. So your answer is whatever I cubed is. I cubed is our -I. I to the eighth will be the next one. 2 ways to do it. You can count 8 spaces around. So 1, 2, 3, 4, 5, 6, 7, 8. Notice the answer in the clock is 1. The other way to do that is to take out multiples of 4 for your exponents. So if I have I to the fourth, that leaves me with 4. 8 minus 4 is 4, so I have another I to the fourth. We know that every I to the fourth is just 1, so they cancel out. So we're just left with 1. So anytime you have a multiple of 4, your answer is always going to be 1 because it's always going to end up back here. All right, let's try 4 more examples where they're not in order. So we're going to do 5, 6, 7, and 8. And hopefully by the time we get to the 8th one, it'll make more sense. The next one is going to be I to the 38th power. So what I want to do is I could go around the clock 38 times. 1, 2, 3, 4, 5, 6, 7, 8. Or just know that every group of 4 is going to bring me back here. So for instance, 1, 2, 3, 4, 5, 6, 7, 8, 12, 16, 20. I'm going to keep going to 38, 24, 28, 32, 36. So 36 gets me as close as possible without going over. Then I would go 2 more. So this is what I'm going to do. I'm going to take out the highest multiple of 4 that's underneath 38, and that would be 36. So that's the same as I to the 36. That leaves me with 2 more. So whatever your remainder is has to be lower, that 4 lower. So again, I took 38, I divided out a multiple of 4 to see what's left. Every multiple of 4, remember, cancels out. So my answer is my remainder. I squared. If you look at your clock, I squared is -1. Let's do another one. And again, if it's still confusing, hopefully it'll make more sense as we go through. I to the 21st. You can count around 21 times, or you can take out a multiple of 4. What is the smallest, or what is the largest multiple of 4 that is underneath 21? That would be 20. 4, 8, 12, 16, 20. So I'm going to take out 20 i's. That leaves me with 1 more. So I to the 1st. Any multiple of 4 cancels out. It just becomes a 1. So I'm left with my remainder. Well, I to the 1st, according to my clock, is just I. Let's try the next one. I to the 83rd power. So I can count 83 times around. That'll take a long time. Or I can think to myself, what multiple of 4 is below 83? And that would be 80. If you didn't know that, you can go to your calculator. Here's another way. You can go to y equals and type in 4x. And keep going in your y column until you hit 83. So if you look, 84 is too fast, too front, so we would use 80. So we have I to the 80th. So taking out the multiple of 4, I'm left with 3. 83 minus 80 is 3, so I have I cubed. Every multiple of 4 cancels out, so I'm going to cross that out. My I cubed, according to my clock, is -I. Last one, I to the 40th. All right, I can count around 40 times, or I can take out a multiple of 4. Well, 40 is a multiple of 4. So I can just cross that out, and I'm left with 1. Any multiple of 4 just goes right back to 1. 2 more examples that's going to involve some operation. So this is the last part. So if we put, for example, B, simplify again. We're going to do 2 examples. So a little more complicated. So here's example 1. Can you write for me? There's going to be 3 terms. 5i to the 16th plus 3i to the 23rd plus I to the 26th. All right, what we want to do is simplify this expression. So I'm going to do each one at a time. So I'm going to ignore these 2 at first, and I'm going to start with my 5. So I'm going to bring down the 5. What I want to do is figure out what this is going to be. I want to divide out a multiple of 4. If you notice, this is a multiple of 4, so this is going to cancel out. That means it just becomes a 1. I'm going to move over here. Actually, I can finish this. So again, if it's a multiple of 4, it just changes to 1 according to the clock. 5 times 1 is 5. Now I'm going to move over here. I'm going to bring down the plus and the 3. I want to simplify this. I want to divide out, first of all, my multiples of 4. Well, my multiple of 4 that is below 23 is 20. So if I take away the 20, I'm left with I cubed. So instead of writing it out like this, I'm just going to get rid of the multiple of 4 and write what's left for my remainder. So again, I can look in my table. find the multiple of 4 that is below 23. So I go up here, here's 20, 24 is too high, so I'm taking out 20. That means I'm left with 3, so that's why I put I cubed. Well, I cubed, according to my clock, show our clock, that is negative I. So I'm going to have plus 3 times negative I here. This turns into negative 3i. So I'm going to bring down the 5. And then I have minus 3i. 3 times a negative I is just negative 3i. Moving over here, I'm going to bring down the plus. There's no number in the front, so I'm just worrying about my I. I'm going to divide out my multiples of 4. So if I look at my table, the biggest multiple of 4 below 26 is 24. So if I take out 24, I'm left with 2. So I just want my remainder, I squared. So again, you're dividing out your multiples of 4 because your remainder is your answer. Well, I squared in our table is negative 1, so I have plus a negative 1. Plussing a negative 1 is just subtracting 1. Now I'm ready for my answer. So I'm going to combine like terms. Think about if this was an x, you could not combine it with these two. So if I combine my numbers, 6 minus 1 is 4, and then I'm left with minus 3i. There's my simplified answer. This may seem confusing as a lesson, but when we do the practice assignment the next day, hopefully this will make more sense. One more example, and then we're done. Actually, I think I'll go to another page because I don't want to write too small. So I'm going to go to example C, and I'll have my clock so I can see that. Here's example. Oh, this is example 2 and example B. So last one, can you write 2i to the 13th minus 8i to the 31st plus 7i to the 28th minus 9i squared. All right, so we're going to simplify this. So what we're going to do for each part is we're going to bring down the whole number, and then we're going to change these i's and take out the multiples of 4. So here's what I mean. I'm going to bring down this 2. This I to the 13th, I want to take out multiples of 4 out of 13. So I'm going to go here, look at my multiples of 4. I can take out 12 because 16 is too high. If I take out 12 i's, I'm left with 1 I. So I'm left with I to the first. I to the first is just I, so we're just left with 2 times I, which is 2i. Now I'll move over to this one. I'm going to bring down the minus and the 8. I need to take out multiples of 4 from 33 and write what's left. So if I look at my table, a multiple of 4 is 32, 36 is too high. So if I take out 32 i's, I'm left with 1 I. So that's I to the first. Again, that becomes just 8 times I and minus 8i. And I'm always referencing my clock when I'm using my exponents. Let's try the next one. I bring down the plus and the 7. This is I to the 28th, so I'm going to take out a multiple of 4. Well, if I look, 28's on my list. So that's the same as, you can write I to the 4th, or you can just write number 1, because I to the 4th just changes to 1. So if it is a multiple of 4, you can immediately change it to 1. So we have 7 times 1, which is 7. So I'm going to bring down the plus 7. There's no I anymore in that expression. Moving to this one, I'm going to bring down the 9 with the minus sign. I can't take out a multiple of 4 here because this is not higher than 4. So I'm just going to bring this down. Now I can change it. According to my clock, I look at my clock, I squared is negative 1. So this is going to be the same as 9 times negative 1. Negative 9 times negative 1 is a positive 9. So now I have my expression that I can combine. So if I can combine my numbers, 7 plus 9 is 16, so we have 16. 2 minus 8 is negative 6, so we have minus 6i. There is our simplified answer. So we will be going over this in class on the notes tape more in depth. So if you want to watch this video first, if you've watched it before class, please join us for class and we can go over this together. And the next day when we do the practice, I'll definitely be going over it more in depth. please make sure you post these notes in Canvas.